I can convert fractions to decimals. And decimals to fractions. I can convert fractions to decimals and decimals to fractions. So you'll be given a fraction or a mixed number, and you'll be asked to convert it to its decimal equivalency. Or I will give you a decimal and ask you to convert it to its fraction or mixed number equivalency. Rational number. Rational number. Any number that can be written as a repeated or terminated fraction or decimal. Any number that can be written as a repeated or terminated fraction or decimal. Rational number. Are there unrational numbers? Yes, those are called irrational. We'll talk about those later. Rational number. Here are some examples of rational numbers. 0. Can 0 be written as a fraction? No. 0 over 1. Yes, it can be. 0 over 1. How about negative 6? Negative 6 over 1. $17. Can 17 be written as a fraction? 17 over 1. $15/4. That is a rational number. Because if we were to simplify that, it would be 3 3/4. $11/16 is a rational number. 1/1000 is a rational number. 24/100 rational number.
Is that ever a rational number?
Negative 3 16/100. What was your question?
Is every number a rational number?
Yes.
And what's the point of them making a category of that?
Because you can also have irrational numbers.
What numbers are those?
I knew you were going to ask that. So these are all rational numbers. Any number you can think of. Give me a fraction, Abby. Come on. I like it. 20 32nds. Which reduces to 625 1,000ths. That is a terminating decimal. Therefore, it's rational. 20 32nds is 0.625, which is terminating. That means it is rational. Can anybody give me a repeated decimal? Alex? 1/3. Anybody know what 1/3 is? Yep. 0.33333333333333333. That is called repeating. That is also a rational number. Even if you got this, because there are some fractions that their decimal equivalency is this. Four nine four eight five 49485 49845 49485 49485. That is repeated. Is that a rational number? Absolutely. So any repeated or terminated value is considered rational. Mr. Meeks, can you give me an example of something that's not rational? And there's a big one. It has to do with circles. It's even a dessert. Sydney, pie. 3.14159265437899102, and that's all I can really remember. I'm smart. So, does this repeat? No. Does it ever terminate or stop? No, it goes on forever and ever and ever and ever. It never repeats. Therefore, this is not rational. It's irrational. Other irrational numbers, if you are wondering, would be like the square root of 10. Now, before I even go any further, does anybody know what the square root of 9 is? Alex, raise your hand, please. And next time you give an answer, please give the correct one. Square root of 9. Maddie, 3. Square root of 25. 5. Square root of 81. 9. Square root of 36. Square root of 4.
2.
Square root of 16. Square root of 16. Emily. Oh my God. Preston. Yeah, 4. 4 times 4 is 16. Square root of 49. Nico. 7. Square root of 64. Robbie. Square root of 100. Peter. 10. Good. Square root of 144. Jack. 12. Okay, so now you know those are called perfect square roots. Square root of 10 is not a perfect square root. The square root of 10 is 3.162277665538.9, and then it keeps on going forever and ever and ever. Does it ever repeat? No. It never repeats. Well, what about this 77 here, Mr. Meeks? Well, if this would have been 3.777777, then yeah. Or if this would have been 3.167716771677, that's repeating. But just because it repeats twice, it's not considered repeating. Sorry about the glare. But right. Is there some sort of pattern?
Like how the numbers go?
No.
So couldn't it just be, couldn't it just
Well, it would be 3.1. You can't say 3.9. We just shorten it to 3.14. No, you can't say any random number using long division. Pi is the circumference of a circle divided by its diameter. So, for instance, if the circumference of a circle is 18.84 and the diameter is 6, guess what the answer is? 3.14. And then it keeps going on and on and on and on and on and on. Never stops. Ethan. Give me a number.
17.4.
17.4?
Yeah.
All right. 17.4. 54.636 divided by, whoops. What was it?
17.4. That's cool.
3.4. 3.14.
No.
Oh, of course, Nico, of course. Give me a number. 175,000.3. Well, now you're getting to be a little bit ridiculous, but I gotta write this down. 5. Do you remember your number? Okay. Here you go, Nico. Just for you.
You forgot the coin. Wait, no, you didn't.
What was your 75?
175,000.
Whoops. Hold on. 175,000.3. Okay, so 175,000.3. There you go, Nico, just for you. Pi. There it is. Crazy. All right, so any number that repeats, any number that terminates, that is a rational number. Now, let's talk about converting from one to another. First thing we're going to do is convert from a decimal to an equivalent fraction. Now, in order to do this, all you have to do is ask yourself, how would I say this integer, how would I say this value as a big boy or as a big girl? Because we're not going to say 0.27 anymore. Okay, maybe in 6th grade that's what we did, or 1st grade, but we're not going to say that anymore. So how would you say that, Juliana, as a big girl?
2,700.
Right. And that's how you would write it, 27/100. Exactly. All right, Jack, how would you say 3.04 as a big boy or as a big girl?
3 400.
Now, why is that the wrong answer? Why is 3 400 the wrong answer? Ethan.
Because, I don't know.
Katrina. No. Alex. Oh boy.
It's a mixed number.
Great. Why is this wrong? Rye.
Because you don't put a whole number in a fraction. So
Yeah, you do. It's called a mixed number. Preston. It's not simplified. It's not simplified.
I know how to simplify it though.
We could divide this 2 ways. We can divide this by 2, Or we can divide this by 4.
4.
If we divide this by 4, we're going to get 3 and 1/25. 3 1/4. Or 3 and, not a quarter, 3 and 1/25. All right, what about negative 0.306? It's nasty. How about that one, Drake? How would we write that as a big boy or a big girl? Is that simplified?
No.
So how would we simplify that, Gavin? We can divide both numerator and denominator by which number, Peyton? You're Peyton. Okay. Jack?
2.
Yes, they're both even. Therefore, they are both divisible by 2. And we would get negative 153/500. If it's an even number, they're both divisible by 2. All right, how about negative 1.64? How the heck would we say that number as a big boy or as a big girl? Paris.
Negative 1 and 64, but it's not simplified.
Keep going.
It's not simplified.
Okay. Can you simplify it for us or no?
30. That's still even.
Okay.
Am I right?
Yeah, that's good so far. Are you done? Okay. Bella, are we good? Don't know this answer. Brandon.
16/25.
Nice.
So our answer is 16/25. You guys agree? I don't agree either. Why is it wrong, Eric? Maddie? Nope. Nico? Got to bring that negative 1 over. So the answer should be negative 1 and 16/25. All right, so now we're going to take a look at 4 examples turning a fraction into a decimal. So in order to do this, we have to use what's called long division. So what number is it the numerator or the denominator go outside the house? The division bracket. Is it the numerator or denominator that goes outside? Bella? The denominator is correct. Good job. I know. So we have a 4 and a 9. Which one's the numerator and which one's the denominator, Haley?
The denominator is the 9, and the numerator is the 4.
All right. So how many times does 9 go into 4? 2. So, okay. 2 times 9 is 18. You said 2.
I said 2.
You both said 2.
I said 0.
So then how are we going to divide this then? This doesn't make sense. I've got the answer 0? Maylin?
You add a 0 after, you put a decimal point in there.
Okay. So how many times does 9 go into 40? Paris.
4.
9 times 4 is 36. Uh-oh, I have a remainder. Now what do I do? Oh, just keep going? So 9...
Keep going. The answer is just going to keep going.
It's going to be 4, 4, 4, 4, 4, 4, 4.
So then our answer... Okay, I'm glad you guys saw the pattern. So the answer is going to be 0.4 or 4/10 with a line over it. That line tells you it goes on forever. Is this a repeating decimal or is this a terminating decimal? Terminating. Or repeating? Repeating. That is called repeating. Repeats itself. 4, 4, 4, 4, 4, 4, 4, 4, 4. All right, let's take a look at 12/20. 12/20. Now, guess what I could do before I divide this? Haley? We can simplify this to make our life a little bit easier. And what is the greatest common factor? Shh. What's the greatest common factor, Haley, of 12 and 20?
4.
And what is 12 divided by 4?
3 and 5.
Very good. So, Bella, which one of those numbers is going to go outside and which one's going to go inside? That's fantastic that you told me that, but I have no idea which one's the numerator and which one's the denominator. Like which number?
3 is the numerator.
Okay, so where does the 3 go?
3 goes on inside.
Inside? Like this? Good. How many times does 5 go into 3? 6.
Oh, 0.
Then we add our decimal.
Now it's 6.
5 goes into 30. 6. 6 times 5 is 30. So 12/20 is equivalent to 6/10. Is that a repeating or a terminating decimal? And so then we would write terminating. That's a terminating decimal. All right, let's take a look at the improper fraction of 20. Let's do negative. How about negative 24/5? Negative 24/5. Can't simplify this, so then we just have to ask ourselves what number goes inside and which number goes outside, Emily Rogers. Very good. And how many times does 5 go into negative 24, Marina?
4.
And 5 times 4 is 20. So is my answer 4, negative 4, remainder of 4? No, we got to add our decimal, add our 0. How many times does 5 go into 40? So our answer, now is that repeating or terminating? All right, here are your 4 practice problems for this evening. I know I said I'm giving you 4, but I'm actually giving you 5. I know. I figured you guys would want more.